Good morning everyone, I hope you all are doing well. Today we will look at discriminant, and in the following videos we will look into calculus and how we can use calculus and plot quadratic graphs. But today it's all about discriminant and the nature of roots, so we'll go straight into the example. We want to see how we can find the discriminant here. As discussed in the previous video, discriminant basically comes from the quadratic formula. So we can notify discriminant by saying discriminant is equal to b squared minus 4ac, and after that we will try to find our values a, b and c. So a from this equation, remember a is the coefficient of x squared. In this case the coefficient of x squared is half. Okay, remember we can write x squared over 2 as half x squared minus x minus 2 equals 0. Okay, so therefore a is basically half, b here is minus 1, and c is minus 2. Now we can go ahead and put this in the formula. So discriminant is equal to b is negative 1 squared minus 4, a is half, and c is minus 2. So solving this, so negative 1 squared is a positive 1, and half of minus 2 is minus 1, and minus 1 times minus 4 is a positive 4, and therefore the discriminant here is 5. So what do I do with this? What does this imply, or what does this mean? So whenever, okay, you can make a note here. So whenever the discriminant, okay, is equal to 0, that means that there will be one real root, one repeated real root when the discriminant is equal to 0. When the discriminant is negative, right, which means basically less than 0, there will be no real roots. No real roots. The meaning of this is, if you have one real root, this means that for a quadratic graph like this, your graph looks something like this. Okay, it turns on this turning point, and this turning point is your root value here. Okay, it can also be a negative graph whereby the graph is like this, and again you just have one real root over there. Okay, now if you have no real roots, this means that a graph is something like this. It does not have any x intercepts. It can be there, it can be here, it can be here, anywhere apart from the x-axis. So it has no real roots. And if your graph, if your discriminant is positive, which means if it's greater than 0, then you will have two distinct, okay, real roots, which means different real roots. Your graph can look something like this, whereby you have a positive and a negative, or you can also have something like this, okay, whereby you have different roots. Roots basically means the x intercepts. Okay, so knowing these 3 points, from here we can see that we get a positive 5, and therefore I can say, therefore there are two distinct real roots. There are two distinct real roots because the discriminant is greater than 0. Okay, so if your discriminant was negative, you'll say no real roots, and if your discriminant was equal to 0, you'll say one repeated real root. Okay, so that is basically it for the first example. Let's have a look at this example as well. Here we have to find the value of k, And because it has only one real root, this tells us that discriminant is equal to 0. So let's identify our given values. A here is a -2, B is k, the unknown value that we have to find, and C is -2. So let's solve this one. Discriminant is equal to b squared minus 4ac. Discriminant here is 0. B is k minus 4. A is -2 and C is minus 2, not 3, 2. Solving for k, this becomes k squared minus, so that negative times a negative will give you a positive 4. That's 4 for 16, so negative 16, and this is equal to 0. Taking the -16 to the other side, becomes a positive 16 and k squared. Taking the square root of k to the other side, k is equal to plus and minus 4, because whenever you're taking square root, remember, you'll have a positive and negative value. So therefore you can say that k is equal to positive 4 and negative 4, or k is an element of negative 4 comma positive 4. It's a professional way of saying it mathematically. Let us do one more example, and then I'll give you some activities. You can try that out on yourself. So here once again, let's look at this. Has only one real root, so this means discriminant is equal to 0. Let's identify all our known values. A is equal to 1, B is equal to k, C is equal to positive 4. So let's say discriminant is equal to b squared minus 4ac. Discriminant is equal to 0. Sub in the values. B is k squared minus 4, a is 1, c is 4. Solving for k, this becomes k squared. This is 4 for 16. So once again, I think same solution. This is positive 16k squared. Taking the square root on the both sides, k is positive and negative 4. Therefore we can say k is an element of negative 4 and positive 4. So this is student activity, and you all can try this out. Let's say this is question 1 and this is question 2. It's a good way to get a feel of those examples. So you can solve the problems, drop it in the comment section. I'll be sure to verify your answers, and have a great Sunday, guys.